Part H, harder trig equations. We're going to deal with these again over the interval from 0 to 2 pi, and these will involve doing a little bit of algebra, doing a little bit of factoring, to be able to turn the harder trig equations into equations like those simple ones we were looking at. We're going to start from the equation 2 sine squared theta equals the sine of theta. This is sort of like the non-trig equation, 2x squared equals x. It might be tempting in this equation to divide both sides by x, but you can't do that because if you do, you'll lose some solutions. What I would do with this equation is subtract x from both sides and then do some factoring once it equals 0. I'm going to do the same thing over here. I'm going to subtract the sine of theta from both sides, giving me 2 sine squared theta minus sine theta equals 0. Now that it equals 0, I'm going to factor out my GCF. I'm going to get the sine of theta times 2 sine theta minus 1 equals 0. And I'm going to set those two parts equal to 0. I get the sine of theta equals 0, and I get 2 sine theta minus 1 equals 0, which becomes, after you solve for theta, the sine of theta equals 1/2. Add 1, divide by 2. Now I have two simple trig equations that I can just use my unit circle to solve. Where is the sine of theta, the y-coordinate, 0? That will occur at 0 and at pi. Where is the sine of theta, the y-coordinate, 1/2? That will occur at pi over 6 and 5 pi over 6. I have 4 answers to this equation. Next, let's take a look at the secant squared of theta plus the secant of theta minus 2 equals 0. To compare this to a non-trig equation, kind of like x squared plus x minus 2 equals 0. I can't factor out a GCF here, but I know how to factor this quadratic and can factor that into x plus 2 times x minus 1 equals 0. I'm going to do the same thing over here, just treating the secant of theta as my variable. I'm going to get the secant of theta plus 2 times the secant of theta minus 1 equals 0. Now we can set both pieces equal to 0. Secant of theta plus 2 equals 0, and the secant of theta minus 1 equals 0. Solving these, I get the secant of theta equals negative 2, and the secant of theta equals 1. Well, the secant of theta, that's just 1 over the cosine. So 1 over the cosine of theta equals negative 2. 1 over the cosine of theta equals 1. Find the reciprocal of both sides in both equations, and you get the cosine of theta is negative 1/2, and the cosine of theta equals positive 1. Now, what angle has a cosine of negative 1/2? Well, that will occur at 2 pi over 3 and 4 pi over 3. And what angle has a cosine, an x-coordinate of 1? Well, that's just going to be 0. Your 3 answers are 2 pi over 3, 4 pi over 3, and 0. Next, let's take a look at the cotangent of theta. Whoops, that's not right. The cotangent of theta times the cosecant of theta minus 2 times the cotangent of theta equals 0. It's a little strange that I have two trig functions mixed together here. However, if you factor out your GCF, we can split up those two trig functions. We can say the cotangent of theta times the cosecant of theta minus 2 equals 0. And setting them equal to 0, we get the cotangent of theta equals 0, and the cosecant of theta equals 2. Well, the cotangent is the cosine divided by the sine. For a fraction to equal 0, the numerator needs to equal 0. So I need the cosine of theta to equal 0, which will occur at pi over 2 and 3 pi over 2. Here I have the cosecant of theta equals 2. This is 1 over the sine of theta equals 2. So the sine of theta equals 1/2, and that will occur at pi over 6 and at 5 pi over 6. So these are my 4 answers. One more. Let's look at the secant squared of theta equals 2. Sort of like the non-trig equation, x squared equals 2. Well, to solve this one, all you would do is take the plus or minus square root of both sides to get x equals plus or minus root 2. And that's exactly what I'm going to do over here. I'm going to say that the secant of theta equals plus or minus root 2. So 1 over the cosine of theta has to equal plus or minus root 2. So just the cosine of theta has to equal plus or minus 1 over root 2. I'm going to rationalize my denominator, giving me the cosine of theta equals plus or minus root 2 over 2. Now we just have to find those angles whose x-coordinate is either root 2 over 2 or negative root 2 over 2. This will occur at pi over 4, at 3 pi over 4, at 5 pi over 4, and at 7 pi over 4.